What's up, everybody? So today we're going to talk about how an FTC robot works.
Triple 172 stat discharge. So today we're talking about everything involved in making your robot run.
Yep.
So
It all starts. Let's see. So let's start off with the code.
Most important.
The robot cannot run without the code. All right.
Yep. That's what our programmers, like me, that's our job. We're able to type it away on a computer.
Yep.
That code is uploaded to the controller on the robot.
The controller. This is called the robot. This phone right here. You have two phones. One of them is called the driver station. The other is the robot controller.
Yes. So our code from the computer is one wire end goes in the computer, one wire end goes in the robot controller, and it's uploaded. So you can do this multiple ways. You can either do it over something called FTC blocks, which is like drag and drop block programming from the computer over Wi-Fi to this phone, or you can use a cable, plug it in there, and upload straight from Android Studio.
Yep.
Both work for new teams and especially new programmers. I've heard this is a great strategy, but our team uses Android Studio and codes in something called Java, popular programming language that I think most people in the industry use as well.
Majority of people in FTC, they utilize Android Studio. Some people they utilize FTC Blockly. Why? Because most people that when they come to FTC, they come from FLL, where they're used to drag and drop programming. But if you want to be an engineer later in life, you know, I would highly recommend learning Java and utilizing.
Trust me, there's other reasons like special FTC libraries, which are great for doing stuff like advanced path programming. You're gonna want to use Android Studio.
Yep.
Okay, so after you upload this code to the robot controller, which pretty sure the FTC guide explained how to do that pretty well.
This controller connects all the motors, all the servos, all the sensors, everything on your robot, hardware-wise.
That controller, most of the time, is going to be a Rev expansion hub, or two of them.
Yeah. Yeah, we can talk about that right now. So, in our previous video, we talked about the design process, and we talked about your constraints, your limitations. In FTC, you have a limitation of 2 robot controllers.
Yes. So what that means is they have a maximum of 8 motors, and I believe 12 servos. Well, this may change in the future.
Yep.
As of right now, it looks like these are the constraints to stay. So what that means is you have to consider when you're making changes, how many motors will this take, and is it worth it to sacrifice these motors to achieve this goal?
Yes.
Yes, that's a very big problem. Also, all this stuff has costs, so you gotta weigh that as well.
Yep. All right. When you're programming, you're not only programming autonomous, you're programming a period called the teleop period, the driver control period. So in the driver control period, there's another phone, and that's called the driver station.
Yes, that's where your commands from the gamepad are sent to the phone.
Yep.
So the phones are the only two things that talk to each other over distance, right? You can't talk the controller, this controller to the gamepad, or you can't do like computer to gamepad or anything. It's really phone to phone as much as possible.
In an FTC match, the connection between the robot controller and the controller on the robot.
Usually that's an expansion hub, so we might as well clarify that now.
Yeah, the Rev expansion hub. That's really important. If this goes out, if your connection right here is loose, you'll find your robot
will suddenly stop moving.
Yep.
Basically.
Yeah. Another thing you'll find is the field tech inspection person at the meets always checking for Wi-Fi signals. They'll tell you to turn off your Bluetooth signals and all that.
Switches and stuff, Nintendo switches, all that stuff. Any like Nintendo like peer-to-peer connections.
Because that can interfere with the Wi-Fi direct signal.
Big time.
And think about all the robots at the meet that rely on this connection between the driver station and the robot controller.
Remember try to be courteous to other teams. Turn off your Wi-Fi direct if you're not in a match, if you can, you know, because the more Wi-Fi signals in that building, the less likely they'd be able to connect well.
Yep. So there are 2 ways to improve that connection between the 2 phones. The first way is what everyone should be doing. That's constantly updating your phone, making sure that it's in the latest software, Making sure that the actual apps are up to date, stuff like that's really important if you want your robot to perform well at the meets. Actually, wanting to be able to participate in an FTC meet if these two are not up to date with what the league wants.
Exactly.
That's important. And the second thing is the FTC Rev Control Hub.
So the Rev Control Hub basically integrates the robot controller with the expansion hub. So it takes the place of the expansion hub while acting as a robot controller, and it connects directly to the driver station. So what that means is that this connection doesn't exist anymore. So all you have to worry about then is your Wi-Fi direct signal and this connection.
Right, you don't even have this phone.
So that's a whole, like, a bunch of points of failure that are completely removed. Although it's costly, it's like $300. We would recommend teams that are financially able to buy this, just because it is great.
It can save you a lot of...
and it got real legal, so...
It's legal now, so we'll put that in the description for you to look into that. But yeah, so that's basically an overview of how the robot works. You know, it all starts off with the code, gets sent to your robot controller if you have one, unless you have the control hub. Then that robot controller, it talks to your driver station through Wi-Fi Direct. If you are in autonomous, all that code that the programmer programmed into the phone will go to the controller and spread out, assign whatever motors are moving, all that stuff. If you're in teleop mode, you have your controller user input goes to the phone, connects to or sends data to the robot controller, and does it again.
Yeah.
So that's a quick overview of how an FTC robot works. This is our 4th episode in FTC 101 for Dummies. You'll see so many more videos soon.
We're 11172. I'm Yash.
I'm Aman.
Peace out.
See you next time.
Gotta go hard. I ain't got time to waste.